Hi, this is Mahi. Today I'm going to show you how to use the Simplus VREP simulation for RoboCup Rescue. I use the Ubuntu 18 for this practice, but you can use other OS. The instruction is very similar. So first step, you need to go to the directory where you download or clone the simulator. So for me, it's in Simplus VREP. Then we move to the easy setup directory, and then we select the version of OS that we use. It can be Mac, Ubuntu 60 or 80 or Windows. So I go to Ubuntu 80, and I can run these two scripts to run the simulator. If you use the simulator version 4, you can run the V4, and if you use version 3, you can just run the simulator that's shell. Okay, so I run the simulator V4. Never mind this. Okay, now I'm going to tell you how to use the simulator environment and what are each window that you can see in this. Okay, now I'm going to show you how to use the VREP simulator and what is the purpose of each window in the simulator. So as you can see, there is a Simplus monitor. It shows all the information that we can receive from the robot, and also we can command the robot to move forward, move backward, turn to right or turn to left, and stop in case that robot is moving. There's a camera over here that you can see if the robot moves or turns, the image of the camera will change, and you should use this image for understanding the environment and characters. There's a thermal camera with lower pixel density. So if you see an object with heat, you can find it in the thermal camera image. For example, this plate over here has transmitting the heat. So if I look at this plate, you might see this plate in this camera with the other color. You can control the robot LED color, like being red, green, or blue. You can see that it changes on the robot. The important numbers that you might use in this competition are in this field. The top numbers are X, Y, and Z about the robot's location and position. The Z doesn't change, otherwise that your robot move up or down, maybe go to another level of the field. So mostly you don't need to use the Z in the flat maze, but X and Y is changing. If I go to the left or right, the X will change. If I go to up or down, the Y will change. Similarly, the row and file will not change other than your robot fall or your robot trying to go upward ramp. So the number that you should care is only the theta in the flat maze, because when your robot turns, the theta will change. The number you see here is in degree, so you can see it's a start from 0 and go to 306. Okay. The other sensors that we use is proximity sensors. You can see 4 of them are seeing an obstacle. So we have 4 of them here, 1, 2, 3, and 4 that have a value higher than 0. If I move the robot now, 2 of them only see the obstacle. This is number 5, this is number 6. Number 6 is closer to the obstacle, so it has a higher number. If I move closer to the obstacle, they get higher, as you can see here. That means that this sensor is very close to the obstacle. The higher number is the lower distance. And we have 3 color sensors, one in the front, one in the left, and one in right of the robot. When you see a white field, all of the colors are high number. When I move to a red plate, you can see the front sensor, see the red plate. So if the front sensor red is high, but the green and blue low. And if I move a little bit more forward, the left and the right sensor are also on the red plate. So all of them in the red is high, but other is low. So I'm going to, for example, the black plate here. Now everything is close to the 0. And if I go to the cyan plate here, you can see that somehow the green and blue are high and the red is a little bit lower. Okay. So that's how you can test the robot in the environment and read the sensors numbers and play with the robot to understand simple concept of sensors and motions in this robot. For example, you cannot move horizontally. You have to move forward and backward and turn. So this is important if you want to write a controller for this robot. The other window is only used by the referee. It's used to start the game. This is the time that we have left, and this is the score of this team. Is for this team. So when the referee click on the play, time starts decreasing, and the robot can go and gather a score, like by finding victim, reading tires, and stuff like this. The referee might to relocate the robot in other part of the map, so the robots could explore other part of the map also. The important thing is whenever the referee click on the stop button, this means the game has been done and it is the end of the game. So that's it. I close the simulator, and you don't need to save any changes, so remember to click no. And yes, we close the simulator.